Hello and welcome back to another lecture from organic chemistry. In the last lecture, I initiated the mass spectrometry discussion, and I said we have a sample that we inject to a mass machine, and that sample, it will go through vaporization and also get bombarded with a bunch of electrons, and to create a species that we call it molecular ion, a particle that it has is missing one electron. So one electron ejected from the system, and now we have a radical that it has also a positive charge, and we call it molecular ion, radical cation or molecular ion species. And we show this one by M plus dot. And if it happens, like usually is going to be the last peak that you see it. And then, for example, for methane, that's going to be the molecular ion peak. And if it happened to be the highest peak, also you can call it the base peak. So the base peak is the tallest one. And in this case, also is the last peak that we see. We see also tiny peak after the molecular ion peak. That the reason for it is because we have a carbon that has a molar mass of 13 or isotope of carbon there. And there is no really connection between the base peak and the molecular ion peak. And for benzene, and the molar mass is 78. And if you look for 78, that's the 78, and it happened to be the base peak or the tallest peak. And so I'm going to say the base peak is equal to the molecular ion peak. And both of them, they have like a molar mass or M over Z equal to 78. But if we look to propane molar mass is 72. 72 is here. So that's going to be the M plus dot or the molecular ion. But the tallest peak is here. That's going to be the base peak. And M over Z for it is equal to 43. Now, so as you see, for pentane, the base peak is not equal to the molecular ion peak. But if I subtract those two, if I subtract the M over Z for the molecular peak and the molecular ion peak and the base peak, I will get this. I have 72 minus 43. I will get to 29. 29 is equal to mass of CH3, CH2, or an ethyl group. So what happened? When you bombard, the molecule with a bunch of electrons, those electrons, they can hit anywhere of this molecule. So technically, you have a scissor, and you can use that scissor to cut the molecule from anywhere you want, okay? There is really no much, reasoning behind it. Like, they can cut the molecule from everywhere. Now, yes, maybe when you cut it, you will get really, really unstable species. And because it's really unstable, it's not going to survive. So it's not going to maybe make it to the detector. Maybe you will not detect it. Or if you detect it, because not many of them survive until we detected the intensity. Intensity, it will be small. And when I say intensity, I'm talking about the height. The height of the peak, it will be low. And that's the reason you see some small peaks. Now, if I subtract these two, okay, it's telling me that, like I lost, ethyl group from pentane molecule. Okay, is it possible to lose methyl instead of ethyl? And let's give it a try. So we said this one is 72. Question is, what's that peak? That peak, if we looked at it, so we have 55, 56, 57. M over Z is 57. And we said, this one is the molecular ion peak. Okay, let's subtract these two and see what we get. So we have 72 minus 57. Okay, and that's going to give me 5, 1. Okay, so I got 15. And that 15, it can be equal to mass of this species. Mass of methane, methyl group. What does it mean? It means this peak, the M over Z equal to 57, is equal to molecular ion peak minus 15, or a methyl group. Okay. Well, that peak, the base peak, we said is the molecular ion peak minus 29, which was ethyl. So as you see, you can put your scissor everywhere and anywhere of that molecule and start chopping it. If I chop it from here, I get, a minus 15. If I chop it from that one, I get a minus 29. And then, of course, if I keep, cutting it, I might get, like also CH3. And that's the CH3. Okay. I just run 15. I want to know, how do we use those fragments, mass of those fragments, to technically identify the unknown sample, or to confirm whether we got the sample, we made the sample that we are looking for it or not. Okay. First thing is that you need to identify is going to be the molecular ion peak. I said usually is the last one. Okay, the last one. And if it happened to be the tallest, then your base peak is equal to the molecular ion peak. Next thing is, if you know the molecular peak, that means you got the molar mass of you got the molar mass of the sample. So you have the molar mass of your sample. Now, if you have some info about it, let's say you know exactly what actually you made, you compare those molar masses, and that's going to tell you whether you made the compound or not. Okay. Next thing is, check the number that you see. If it's odd, it means you do have nitrogen atom. Okay, so if it's 71 instead of 72, that's a sign that you have nitrogen atom. But if you get even number, that means you either don't have nitrogen, or you have even number sorry, if it is odd, if it's forgive me, if you get even number, that means you either don't have nitrogen atoms, or you have even number from nitrogen atoms. Okay, nitrogen atom, not hydrogen. And what will happen if it's odd? That means you might have 1, 3, 5, 5 nitrogen atoms. So the number by itself, it can give you a good hint, like that what type of atom you are, or atoms you are dealing with. Let's practice some example. In this case, I have the last peak is hanging around m over z equal to 30. So I'm going to call this one, I'm going to call it the molecular ion peak. And one before it, which is m minus 1, I'm going to call it the base peak. Okay, so the base peak is missing 1 unit, and it has mass of 29, or m over z of 29. Okay, now, how do you want to characterize this compound? It says it's a small molecule. Clearly, the small molecule, because the mass is hanging around 30. Next thing is like that. It says that we are dealing with carbon and carbon. So how about this? Carbon, it has mass around 12. Okay, nitrogen 15, 14, and oxygen 16. So combination of these two, okay, might actually give me the 30. Okay, let's give it a try. So how about this? I might have CH3, CH3, and that has molar mass of 30, or maybe is this one. Okay, I see a peak here that is a 29. Okay, that 29, it can be CH3, CH2, or CHO, CHO. That one also is a 29. All right, so I might have oxygen. Okay, let's work on these two and see what we get. Okay, so I see we have a 30. And how do I get the 30? Okay, again, let's make a space for ourselves. So we have 30. Let's build like a molecule that it has molar mass of 30. Okay, so we said we can have CH3, that's 15. And then CH3, that's also 15. Okay, or we might get this. Let's say we have CO, we need it to be octet. Here you go. That one until now is a 28. I need 2 more to make it 30. So I'm going to add 2 hydrogen atoms to it. Okay, 2 hydrogen atoms plus 2, that's going to be 30. Okay, so until now, I got these 2 possible molecules. Okay, m over z is going to be 30 for both of them. Now, how about this? Okay, can I remove 1 hydrogen from them? Yes, both of them, they have more than 1 hydrogen, so you can get m minus 1, m minus 2, m minus 1, m minus 2. Okay, m minus 1, it will be 29. M minus 2, it will be 28. Okay, 29, 28. Okay, let's talk about this. How about m minus 3? Can I have m minus 3? If you subtract 3 hydrogen from it, what do you get? You get 27. Okay, put a star on this. Okay, can I have m minus 3? In this case, no. No, no. Okay, so this one is no. Because we don't have hydrogen, okay? We don't have the 3rd hydrogen. So I'm going to say, let me go back and check whether I have m minus 3. I see m minus 2, but there is no m minus 3. I don't have it. Okay, so that's a good sign that it says, a good sign that you can use it and say, I don't have 3 hydrogen. It looks like I have only 2 hydrogen. So this one is the possible molecule. Okay, and so now let's go after structure of each of these species like that. M minus 1, or the 29, and m minus 2, and also the 14. What's the 14? So if we lose 1 hydrogen from the system, we get this. We get H, C, O. Okay, we lost 1 radical of hydrogen. Now we have a positive charge. Okay, so we get a positive charge here. This species, it will be stable. How? Oxygen will share a lone pair with carbon and it will make it stable. And because it's really stable through resonance, you will see it as a high peak. And here you go, 29 is really stable because oxygen is using the lone pair to stabilize it. Can I remove hydrogen? Can I remove one H from it? So let's say minus H from this one and see what will happen. If we do it, we get this species. Okay, and that's okay. That's going to have M over Z. Well, over Z equal to 28. Okay, and do I see it? Yes, that's the 28. And so now, how about the 14? What's the 14? Okay, now 14 also, it can give you a good actual hint that's what's the structure. Okay, if you're dealing with this species, carbon that attached to 2 hydrogen and also oxygen, I said you can put the scissor anywhere and cut the molecule. What will happen if I cut the molecule from here? If I cut it, I get this. Let's say you created this cation, and also you got O. Okay, and that's going to be radical. Okay, the mass for this one, M over Z, is equal to 14, and that's a sign that you are dealing with CH2O instead of ethane molecule. Okay, one more question. One of you came with this question, said, Dr. Latifi, you said I can I can go after carbon, hydrogen, carbon, nitrogen, oxygen, and I keep adding hydrogen to them until I get the 30 and see what will happen. Okay, I'm going to go with carbon and nitrogen. Okay, remember, we need to keep them octet. Anything that you start with, it has to be octet. So first thing, let's make it bond here. Next thing is, how about this? Let's give this one 2 hydrogen, make double bond here. Nitrogen is not octet. We're going to put hydrogen there. And now we will have a lone pair there. That's one. Another one, you might say, no, I have only a single bond between nitrogen and carbon. So then in that case, I need to have 3 hydrogens here. And also 2 hydrogens sitting on nitrogen. Of course, you're going to have a lone pair there. Now, check the molar masses. Molar mass, okay. Molar mass, so we have carbon plus oxygen. That's going to be 26. You added 3 carbon hydrogen to it. The molar mass is going to be 29. So not 30. Okay, not 30. So that means this cannot be. How about this? We have, again, carbon, nitrogen, 26. We added 5 hydrogen to them. So the molar mass, it will be 31. Again, not 30. Okay. So as you see, your M over Z, your molecular ion peak is not matching. For the first one is 29 and the second one is 31. So in this case, the molecular ion peak, it will give you a hint that none of this molecule is your unknown sample. And in that way, you can rule out, those two. And the unknown sample is just CH2O molecule. I'm going to stop the lecture here, and thank you very much.